Well, hello. This is a discussion about microphones and audio. For this particular presentation, I'm using a combination of Acrobat to flip through the slides, and I am using QuickTime to record the screen as I do it. And for a microphone, in this particular case, I am using my AirPods Pro. So for the projects, you'll have the opportunity to use all sorts of high-end recording equipment. It's certainly available, but you are not required to use it. It is simply there if you choose to. You will be absolutely fine in your projects using your phone, your computer microphone, your earbuds of whatever type, as long as they can do a decent job recording. So, to start our discussion about microphones, it's important to understand some basic concepts within the world of microphones. They certainly come in many different sizes, different types. They come powered, they come not powered, they come in all sorts of plugs and connectors, and they certainly, like everything else in the world, come in many, many different quality levels. Let's start with the basic kinds of microphones. Now, this is a lavalier microphone. It's kind of in its own subcategory because it may or may not have some of the rest of the features that we're talking about, but a lavalier microphone is basically a microphone that's designed to be clipped on close to the source. Generally, it's wireless, whether it clips, whether it's a magnet, whether it pins on, whatever. You'll see these all the time. Sometimes they go all the way into your ear, but it doesn't really matter so much. It's not something that we're going to tend to use in this course. So the first main category we're going to talk about is dynamic microphones. Okay, this is an example of a Shure dynamic microphone. These are the most common type of microphone for those of you who've been around theater and stages and stuff like that. If you've done any kind of formal presentations or you've watched speakers up on stage saying or doing something. And there's a reason for that. They are very durable. They tend to be less expensive, and they have a cardioid pickup pattern most of the time. Now, we're going to talk about patterns here a little bit later. Um, just hold that in your mind as we're going forward. Now, dynamic microphones are also known as moving coil marks. They're simple and they're durable. Um, that's really the kind of key thing in these particular microphones. Next, we have the large diaphragm condenser mics. They're commonly side addressed. Okay, now side addressed meaning you talk to a specific side rather than the top like you do in other microphones. They are they tend to be very good microphones. They capture higher highs and lower lows than dynamic mics. They're more delicate and tend to not really like loud noise. All right. Now, I want you to pay attention to the symbol on this particular microphone. That actually shows you the pickup pattern that is supported by this particular microphone. And later on, again, we'll see what those patterns mean. The next is the small diaphragm condenser mic. These are also often called shotgun mics. Basically, they are called that because you point them directly at the sound source. Okay. These microphones are best to create natural and neutral sounds. They are very level, very calm, and they work very well. They also tend to be fairly durable and end up in some pretty rough, nasty environments. We also will often see these attached to the top of normal digital single lens reflex cameras as an external microphone rather than using the built-in microphone on a camera. The next category, and really kind of the final category, is the ribbon mic. They're also called the vintage microphone. They tend to use a figure eight pickup pattern. Again, we'll talk about that here in a minute. They have less high end and tend to kind of have a vintage sound associated with them because they were really the first kind of microphone. So they just kind of have that first sound. So earlier I talked about pickup patterns. This image shows the shapes of these patterns. So if we start in the upper left-hand corner with the omnidirectional, so that basically means the microphone is picking up a 360 degrees all the way around it, okay? Omnidirectional makes total sense. We have biodirectional. Now, this is what I earlier called a figure eight. You can see why they call it a figure eight. It's in a figure eight symbol, and it works really well for recording directly in front of it and directly behind it. Now, another one I talked about before is the unidirectional or cardioid pickup pattern. Now, it's called the cardioid because it's a harp-shaped pattern. Hence the shape, like that first large condenser microphone image I showed you, it had this cardioid symbol right on the front of it that told you this is the shape that it picks up, and this is the front of the microphone. That's what all of that meant. Okay. Now there's also another one called the unidirectional supercardioid. Okay, and that has mainly a pattern on one side, but then it has a little bit of pickup for something that's close behind it. Now, some microphones, especially the condenser microphones, allow you to switch between your patterns depending upon what you actually want it to do. So not only do they come in different patterns and different styles, some are actually powered, okay? And the actual term they use for power when dealing with a microphone is something called phantom power. Condenser mics require this power in order to function properly. It's also called plus 48 volt or P48. It's a way of powering the mics using a standard XLR cable without having a huge DC power supply hooked up to it. Now, of course, USB mics can be powered through the USB cable itself, but that's not always the case. Some microphones can also get their phantom power from a battery, but those tend to go through those fairly fast. But here you see the power button on an audio console for when you need the phantom power to be turned on. And again, condenser microphones need this power in order to function. So microphone connections, you heard me just mention the XLR. XLR stands for external line return. Now, this is the most common traditional form of microphone connection that you're going to find. There's three connectors. Believe it or not, there's also four and more connectors available on them. But three tends to be the most common. Okay. This happens to show a built-in one. You'll find these sometimes in the walls of conference halls and such where people can plug in a microphone to get the connection. And these kind of hookups have the availability of phantom power. But if it's not on, phantom power is not on. Okay. Now, some of the XLR connectors also have a 1/4-inch plug smack dab in the middle, which makes them look kind of funky. But you'll still see the left, the right, and the bottom pins of a standard XLR connection. And it's just that the 1/4-inch just plugs right smack dab into the middle of it, and it's supposed to serve the same function. You'll notice that this 1/4-inch connector has three separate fields on it, okay, separated by an insulator washer on there. And so that's also designed to provide phantom power. There's lots of different adapter cables. Okay, this one happens to have the XLR on one side and then a standard 1/4 inch or 3.5 millimeter connector on the other side. The challenge with these is they don't tend to provide phantom power because they were never designed to actually send power to the microphone. So like the one on your computer, which is a 3.5 millimeter or a 1/4 inch adapter, they aren't designed to send that power that the microphone needs. And so you end up having to also provide it with power some other way. This is another example of that adapter. This one happens to have a USB-C on the other side. But this one, you can kind of tell probably has power associated with it, although you'd have to look at the instructions to see if it really had phantom power. The nice thing about this particular adapter is there's a jack on it so that you can run a headset or monitor so that you can hear what's going on. And then that little slider in the middle is actually the mic or the volume for the headset that you actually happen to plug in there. Okay. But again, it's an XLR to USB connection in this particular case. Now, this is a USB adapter, all right? And you can see all the different connections that it has. So on the left-hand side, we have in. On the, excuse me, on the right-hand side, we have in. On the left-hand side, we have USB and main out. So in this particular case, you could use this to provide a connection between XLR or whatever your other microphone happened to be to your computer because you need, if it's going to go into your computer, you need some way for that analog style signal to be converted into something USB that the computer can understand. And so it needs some kind of vehicle to actually make that happen. And in this case, it's a USB-C connection. Now, again, if it doesn't specifically say it has phantom power, you're going to need to find something that can provide that phantom power. Some additional things to think about with microphones. First off, if you look on the left-hand side, kind of with the red and black, so that's a large condenser microphone sitting there on a little platform. But what's around it, what that red represents, is what's called an isolator. It's something that basically protects the microphone from touching anything. It's suspended there using some rubber bands or whatever the isolation method happens to be. This is very, very common with condenser microphones so that you don't get any feedback from anything physical in the environment. Then on the right-hand side, you have windscreens and pop filters, okay? Now, there's also a disc pop filter in front of this condenser microphone, all right? Now, those are meant to help prevent pops or, that quick impact of sound. And in the case of the wind stopper, it's there to kind of muffle the sound. Otherwise, you have wind blowing through the microphone, causing all sorts of different kinds of feedback. This little guy right here is called an isolation shield. Isolation shields can be set up behind a microphone and are designed generally to go on top of a standard microphone stand or however you happen to have your microphone set up. This is a microphone with a boom. Now, this is probably a combination microphone. It's definitely high end. You can see that there's some kind of digital recording device bag that the sound person has around their neck. And whether this is a combination of multiple condenser mics, yeah, there's also probably a power supply to provide phantom power in that bag that he happens to be wearing. And then there's also probably a shotgun microphone in there as well. And generally, it would also be covered with a windscreen, kind of a thing that looks like a big fuzzy sock. You do need to consider the environment when you do happen to record, especially if you decide to go on and be a podcaster or whatever you happen to be. And there's a bunch of different things going on in this particular image. What you see are sound deadening panels kind of located around this setup. And the reason for that is you don't want sound bouncing back to the microphone once it enters the microphone. All right, because walls bounce sound unless you have some kind of deadening device. Now, these aren't rigid panels. They're foam panels, which have lots of air pockets and lots of planes on them so that they can maximize and absorb as much sound as possible and not allow it to ricochet back to the microphone that happens to be recording. In the center under the screen, you can see the USB to computer interface. You can see the pop filter. You can see a large condenser microphone. And in this case, you also have some feedback speakers likely on the left and the right-hand side. We won't worry about the camera in the middle. So let's deal a little bit more with sound. Okay, there is digital sound versus analog sound and digital devices as opposed to analog devices. In this, what we are seeing in this particular slide are digital recording or audio devices. The Tascam kind of in the middle on the right-hand side is probably one of the more commons, and they come in 4-channel or 2-channel. They have where you can actually hook up separate outer microphones rather than using the microphones that are on top. And they're very, very commonly used. Then you also have analog devices, certainly used less often, but still, when you do not want digital in an environment for some weird reason, you can use an analog device. Cassettes use a magnetic method where whatever the sound is recorded magnetically onto the cassette, which can later be converted to digital later on or just played back in an analog format. These were very, very common and still are common. Records are also an analog form of recording because it's physical. It exists in the physical environment, and there's no computer reaction involved in the process of creating or storing the sound. That's what analog recording is about. Software. Now, in using a computer, you will likely also need some kind of audio software. Computer operating systems may or may not have built-in software for this. Like I said, in this case, I am using QuickTime. Apples have QuickTime. In order to be able to do audio or video recordings, we also have GarageBand um, on Macs. Trying to I thought I had a slide for GarageBand, but I don't. Well, this is GarageBand, isn't it? Anyway, we're not going to get hung up on that. Your computer either will or will not have built-in software. The neat thing about GarageBand is that you can edit your recordings. You can also run them through filters and do other modifications to them and join them to instruments or instrumentals or instrumental recordings, which you cannot do with QuickTime. QuickTime is simply a way of recording video and audio, not editing them, simply making them. Windows machines, they have various free or shareware apps that you can use with them. Your phone also has audio software, which I don't have a slide for because everybody's phone has something different. Um, Phones have different ways of recording. Watches even can record audio for you now. But for us, what we will be using is this particular interface you kind of see in front of you for sound editing if you need to do editing. It's Adobe Audition. Okay. This is the one that I will talk about when it comes time to do more comprehensive editing or filtering or whatever you happen to need to do to your audio recording, because all of you have access to it because it's part of your Adobe Cloud software. All right. And it is one of the more common um, audio recording applications because it is part of the Adobe Cloud. So that gives you a broad overlook of microphones. Um, Now, there is a quiz associated with microphones. So while this is all still fresh in your mind, you'll probably want to go into Moodle and go ahead and take that quiz. But I hope you learned something about microphones, maybe more than you ever wanted to know about microphones. But as I said before, for much of what you're doing, you will really not need to delve too deeply into audio. Um, this class is simply not long enough to cover all of the different ways of doing things. And so I'm trying to make it as simple as possible for each of you to be able to at least get the basic concepts down about the different things and have a vocabulary to be able to talk to professionals in the field, or at least figure out what devices or what hardware you actually need for what level of video or audio that you will be doing, um, depending upon your clients or whatever you happen to be doing. Hope that was helpful. Have a great day, folks.